Let's walk through it all from the starting point of sensation to the end point of perception. We live in a three-dimensional world, and the stimulus for vision is light. So think of visual sensation as starting with light waves. More specifically, electromagnetic radiation has a wide spectrum, and the light that's visible to us is just a narrow part of that spectrum. For example, we don't see ultraviolet light, we don't see infrared light, we don't see microwaves, we don't see radio waves, we don't see X-rays. The light we can see is made of whatever wavelengths are illuminating the world around the thing you're looking at. And the reflection of those light waves gets sensed by our eyes, because eyes are the things we have in our bodies to acknowledge light waves. Anyway, back to sensing what we can sense. The visual receptors are located on the retina, which is in the back of the eye, onto which the lens focuses the light into an upside-down, two-dimensional image. On the retina are two kinds of visual receptor cells, rods, which are numerous. There's like 120 million in one eye. They're specialized for dim light, and they are not good at color detection or detail. They provide peripheral vision very well to the sides. And we have cones, which are fewer. There's only like 7 million in one eye. They are specialized for seeing in good light. They detect color, red, green, blue, and fine details. They provide the directly ahead vision and are concentrated in a place on the retina called the fovea, which is the spot of our sharpest vision because there's a bunch of cones there. Both kinds of visual receptor cells, rods and cones, when stimulated, trigger chemical changes which spark action potentials and synapse to bipolar cells, which synapse with ganglion cells, which are basically the optic nerve, which isn't technically a nerve, but an extension of the brain, which is good trivia knowledge. The axons of ganglion cells go through the thalamus to the primary visual cortex, a part of the cerebral cortex located in the occipital lobe on the back of the head. Now in the visual cortex, here's where the brain makes sense of what it has received, recreating what the brain thinks the original three-dimensional reality looks like through a process referred to as perception. And a whole bunch of rules and automatic processes come into place for us to somehow bind together in our brain these multitudinous sources of sensory input to somehow make meaning and interpret the world around us. And so you see whatever your brain decides that you're seeing. Bottom line, we definitely do not all see the same things the same way in the same world. And so yes, you are special.